Okay, question 3. There's a galvanic cell which consists of magnesium 2+ and magnesium and copper 2+ and copper. Okay, which of the following statements is correct? Okay, I've written down the half equation over here. All right. Okay, so the more positive one is the cathode and the more negative one is the anode. Right, so you can see from here E cell is gonna be positive. Here is 0.34. Okay, minus 2.3. All right, so yeah. Okay, but anyway, let's look at which of the following statements should be correct. Okay, if you reduce the size of the magnesium electrode, magnesium actually electrode is the solid. So the thing is, if you change the size, you make it bigger or you make it smaller, all right, it actually doesn't affect the E anode, all right, because this is after a solid. It's like when you do Kc, when you do chemical equilibrium with the Kc, the solid is not part of the equation, correct? It's not part of the equilibrium equation, equilibrium constant equation, all right? So in this case, changing the size of the solid will not affect the position of equilibrium over here, right, for this magnesium, right? Which means so this is definitely wrong because it will have no effect, right? No effect. So the answer is actually no effect. Okay, increasing the temperature has no effect on the EMF of the cell. Okay, if you increase the temperature, what happens is you can actually end up producing more aqueous ions. All right, so in this case, if I increase the temperature, there would be actually more aqueous ions, right? So equilibrium will shift and that will actually affect the EMF. Okay, so I would say this is definitely wrong because yeah, increasing temperature will create more ions. So for example, maybe increase temperature, there'll be more aqueous magnesium 2+ ions. So the E anode will be affected. So let's look at option C. We add sodium hydroxide to the copper half cell, all right? So what happens is you're going to form copper hydroxide precipitate. Okay, this is a solid, this is a PPT. And when that happens, the copper 2+ concentration will actually fall, right? Will actually fall. And this will actually favor the backward reaction. By LCP, it will favor the backward reaction to increase the concentration of copper 2+. And when that happens, when you favor oxidation, the electropotential value will always drop. All right. So when the electropotential of the E cathode actually decreases, what it means is E cell will also decrease. All right. So when they say increase, this is definitely wrong. Okay. So let's look at the last part. Okay, what happens when you... Okay, let me remove this first. Okay. Just take a bit of this. Okay. Let me just write it all again. Okay. So let's look at the next one. So what happens when you add water to this magnesium 2+ half cell? In fact, when you add water, this concentration will actually decrease. So again, by Lachaze's principle, it will favor the backward reaction and you'll favor oxidation. And this will cause the E anode to actually decrease. So when E anode decreases, right, when E anode decreases, E cell will actually increase. So which means this is a correct statement. So the answer should be D.